Hi, my name is Matt Gatica from the University of Michigan. Today I'll be going on somewhat of a tangent to my primary research, nonetheless a necessary one, concerned with anesthesia in wild animals. We are all familiar with analog environments, from Cinder Lakes in the Apollo era to Nemo and Hera. These are places that physically simulate aspects of space missions. They enable agile development cycles, reduce the cost and risk of that development of tools and protocols, and are a great way to see interagency collaboration here on Earth. All analogs strive for an equivalency checklist like this. What about biology and specifically animal analogs? This is when we use animals to understand the biological, behavior, or cognitive effects of space missions. They have similar advantages with regards to development and limiting human exposure. Here we see a mouse in simulated microgravity and the first dog and chimp in space. The way I've consistently phrased the use of quote-unquote wild animals is this. Free-living animals may document or expose potential countermeasures better than animals in comfortable environments. Most of what we know comes from docile, inbred, housed since birth mice and rats, and even the National Science Foundation has publicly recognized the need for non-traditional animal research. Enter the North American red squirrel, which is a tractable diurnal mammal that is an extreme performer in extreme conditions, living in a three-dimensional, complex, arboreal environment. If you've ever watched two squirrels in a chase, you'll appreciate the subtle fact that gravity means a lot less to them than it does to us. But my project goals have to do with manipulating neural rhythms, such that I need brain access, and this led our team to several challenges in performing long-duration surgeries. We think it largely has to do with the stress load of bringing wild animals into a surgical setting, but red squirrels are also extremely lean, meaning that drugs metabolize differently than conventional rodents, and body heat is very important to regulate. We have also identified potential issues with post-surgical recovery using standard methods, as well as logistical challenges of procuring and transporting drugs common to surgery, but which are controlled and require monitoring by the DEA. To outline the specific issue, let's first look at a procedural overview. Animals are trapped in the forest and then transported to Michigan's campus where they are housed in a nice big cage. Before surgery, they are induced to a mild unconscious state to be handled and then maintained under anesthesia during the operation, finally to recover again in their cage. The study moves forward, and if all goes well, animals are returned to the wild. But with only the inhaled isoflurane we use as a primary anesthetic, we experienced fluctuating vitals and we had some animals die. It didn't matter if they were big squirrels or small squirrels, and not only that, if they got to recovery, the after effects were protracted and animals flailed in a sort of post-surgical drunkenness for up to 20 minutes. We thought this might be because their stress axis is redlining, resulting in unstable anesthesia. So I sought advice from a host of professionals in veterinary medicine, and our proposed solution was adding a pre-surgical sedative called dexmedetomidine, or Dex. Without going into the pharmacokinetics, we thought the sedative might mitigate that redlining effect and allow animals to enter anesthesia with normalized physiology. Dex also spares our primary anesthetic, isoflurane, reducing its use to nearly half, which can lead to better long-term outcomes. And finally, a huge advantage of Dex is that it is easily and rapidly reversed, so animals can come back to quickly and humanely. We set up a small study where we monitored vitals during 2 neural implant procedures, only that the first had a bit of an extended preparation period. On the right are heart rate data only, which I'll cover in the next slide. Here's the punchline. Dex worked. The squirrels were stable throughout surgery with nominal vitals. These plots show heart rate relative either to the start or end of surgery, that's the left and the right column respectively. And the top row is beats per minute, where the bottom row is z-scored. You can appreciate the cardiovascular depression typical of Dex at the beginning of the surgery. Heart rate increases not only because Dex has a relatively short half-life and it's being metabolized, but surgical manipulation will also increase heart rate. Nonetheless, these data are within normal limits and provide a good reference for the future. To sum it up, adding Dex to isoflurane allowed us to perform long-duration surgeries without incidents on wild red squirrels. Both substances are not controlled, making this widely applicable. So back to my primary research focus, where I'm implanting wild squirrels with little Bluetooth-enabled recording devices. Through my iOS connection, I can transmit and receive data to the implant and coordinate closed-loop audio stimulation experiments. Although I didn't spend much time on that work today, you can find me online. But taken together, this tangent has led to very meaningful collaborations with field experts and given me the tools to continue working with non-traditional animals. Thanks for joining me today, and I look forward to meeting you at the conference.